Dear students, welcome to our class on vegetative indices and yield forecast. This is one of the topics for the PG and PhD in addition to JRF, SRF and NET exam. Even during the interviews also the information is useful what we are discussing. This is only a basics in the advances, the first stage of advances in other words. Now in this class we are going to study how we can forecast the yield based on direct methods and indirect methods. Direct methods and indirect methods of remote sensing. Of course, vegetative indices. Please subscribe to my channel Agrometrology, Farmers and Rural Development. There I have given the basics at least in 5 classes. First you understand that one. Then how actually as a service, meteorological service, remote sensing as an agrometeorological service, it has got wonderful information. It provides excellent tools and services. I have the privilege of working with international scientists on remote sensing in United States Department of Agriculture, USDA, Belts Valley, Baltimore Laboratory during 2006 and 7. There we work on nitrogen requirement of corn crop, also on several other crops. We have got the data from Moody's, satellite Moody's. We developed a lookup table, LUT, along with me, scientists from different countries, even Russia, Europe, European countries. So in a very simple way, what is a direct method of yield estimation through remote sensing? What is the indirect method of yield estimation? That's what I am going to tell you in a very brief form. Now, as you know, there are 2 indices. Basically, number 1 is the ratio vegetation index, RVI acronym. This is in general in the remote sensing, the common practice is use of band ratios. That's why I request you to subscribe to my channel. Agrometrology, Farmers and Rural Development. There I had given what is the band ratios. Again, covering it at the advances, beginning of the advances may not be good to a professor. Okay. Now, use of band ratios to eliminate various albedo effects. Albedo is the ratio between the reflected and the incident radiation on certain objects from the remote sensing satellites. Now, of course, the NDVI I have covered extensively. No need for covering it again. The vegetation indices assume that external noise. What are the external noises? Say for example, atmosphere gives some external noise, soil background will give some external noise. So atmospherically resistant vegetation indices, atmospherically and soil resistance vegetation indices, because atmosphere offers some sort of noise, soil offers some sort of noise while taking the remote sensing data. For direct methods and indirect methods. So advances are coming slowly in the year 1992. First atmospherically resistance indices were developed in the year 1995. Soil and atmospheric resistance indices were developed while taking the images. Now, if you see how we can estimate the yield as far as the crops are concerned, yield estimation, that's what I am telling. I have worked on the Moody's data. How? In the first direct method, we directly measure the data. We get the data from Moody's. So in that, what we do in the direct methods, for prediction of yield of any crop using remote sensing data, as a reflectance or thermal parameters we took. This bit will come. Reflectance or thermal parameters we use in the direct methods. Now, these 2 reflectance or thermal parameters have been successfully applied in various crops through Moody's data. Absolutely no problem. So we can predict the yield of, we can forecast the yield of certain crops based on the direct methods, where a bit will come, where we use the reflectance or thermal parameter. Now, what is the second one? Indirect. what is meant by indirect method of vegetative indices for yield forecast. In this, what we do is, in this indirect method, remotely sensed data are incorporated into simulation models. Remotely sensed data, we get it. We incorporate it into simulation models. So once we put it into the simulation model, so they give a lot of information and we give the yield forecast. So this is the basis for our advances beginning. Okay. Now, remotely sensitive vegetation indices later that were developed include not only ratio vegetation indices, NDVI, I have discussed enough on these two earlier classes. Please, the other indices include green leaf area index, Greeness index, vegetation condition index VCI, transferred soil adjusted vegetation index, fraction of absorbed photosynthetically active radiation index. Okay, many other indices were developed based on the NDVI. Now, as far as the visible and infrared parts of the solar spectrum is concerned, a bit will come, and even in your practicals also, when you, it is we, the agrometeorologists, who should use remotely sensed data for yield forecast. No other science will do it. So, this is very important. The visible and near infrared bands on the satellites, multispectral bands. Multispectral advanced very high resolution nanometers. So two nowadays excellent sensors have come. Again I will read. The visible and near infrared bands of the satellites, multispectral bands allow monitoring of the greenness of the vegetation. Stressed vegetation is less reflective in the near infrared and as compared to non-stressed, okay, and non-stressed vegetation, and absorbs less energy in the visible band. Once again I will read. The visible and near infrared bands on the satellites multispectral bands allow monitoring of the greenness of vegetation. The stressed vegetation is less reflective. Stressed vegetation is less reflective in the near infrared channel than non-stressed vegetation and also absorbs less energy in the visible band. Thus, the discrimination between the moisture stress and the normal crops in these wavelengths is most suitable for monitoring the impact of the drought on vegetation, thereby yield forecast. Then last thing is, as far as NDVI is concerned, for more dense crops, the NDVI varies between 0.1 to 0.6%. For rock and bare soil, it is 0. For clouds, particularly cirrus, cirrocumulus, cirrostratus, okay, water and snow, it is 0. So, as far as the other one, that is the first one, ratio vegetation index is concerned, it varies from 0 to infinity. RVI 0 to infinity, NDVI -1 to 1. These are the ratios. Thanking you for your patience here.